So I changed these to fractions because the answer is being asked in fraction format. So that is 5 over 12, 1 over 2. When we divide these two, we get 5 over 6. Alright, next question. So in number 6, we have a box with balls numbered 1 through 17. So we want ball 1 to be less than 4 and ball 2 to be 4. So I put B1 less than 4 and B2 4. So the question says, and the balls are drawn in succession without replacements. So that means you pull one and then you don't put it back in and you pull the second one. If the second ball has the number 4 on it, what is the probability that the first ball had a smaller number? So the question is, what is the probability that the first ball is less than 4, the number of the first ball is less than 4, given that ball number 2 has a 4 on it? So this is conditional probability. So on top we put B1 and B2 happening together, meaning that ball 1 is going to have a number less than 4 and ball 2 is going to have exactly 4 divided by the second ball being 4. So that's essentially like pulling a ball with a 4 on it. So what is B1 and B2 happening together? So first ball is going to be less than 4, so that could be 1, 2, or 3. So that's 3 possibilities out of 17. And then we multiply that by ball 2 being 4, which is just 1 out of 16. This is 16 because we already pulled the ball, and there's now 16 left, and only one of them have a number 4 on it. So that's why this is 3 over 17 times 1 over 16. And then here, this is the probability of pulling a ball that has a 4 on it. So that's like starting from scratch. And that can happen only 1 over 17 because there are 17 balls. So now we're going to divide these two. So 3 over 17 times 1 over 16 divided by 1 over 17. That 17 is going to cancel that out. So the answer would be actually 3 over 16. So that's number 6. And then number 7. So number 7 is asking the expected value. And expected values, remember, it's you multiply the value of x with the probability of x. And you do that with everything on the probability distribution table, and then just add them up. So here, the expected value of x would be actually going through here, that would be negative 3 times 0.3. So I'm putting negative 3 times 0.3, and then plus, moving on to the next column, 2 times 0.5. 2 times 0.5 plus, and then the last one 6 times 0.2, 6 times 0.2, and that's 1.3. So that's the expected value for this probability distribution. Okay, so number 8 is a little bit of tricky. So it says here a die is rolled 3 times. So we're rolling a die 3 times. And so this is a game. So when you roll it 3 times, if you roll 5 at least once, you lose $13. And you will win $8 otherwise. So when you roll it 3 times, if you roll in all 3 times anything other than 5, you win $8. So there are 2 probabilities we need to calculate. The first one is not rolling 5 at all in these 3 rolls. So that would mean, so we're going to roll it once. You want it to be anything but 5. So that's 5 over 6. Why is it 5 over 6? Because it could be 1, 2, 3, 4, and 6, but not 5. So it's 5 over 6. And then you roll it again, and you don't want it to be 5, which is again 5 over 6. And then you roll it again for the last time, third time, and that's again 5/6. Because 5/6 is the probability of it. This is not a dollar sign. So that's the probability of rolling 3 dice and not getting any 5s at all. So when that happens, you win $8. And on the other hand, if you roll 5 at least once, which is actually the opposite of this event, right? So instead of trying to figure out how can I get 1 5 and 2 other numbers, and then 2 5s and 1 other number, that would be too much to calculate. So instead what we do is we subtract this probability from 1, because 1 minus the probability of not rolling a 5 at all would give you the probability of rolling at least 1 5. So that's this probability, at least 1 5. And when you roll at least 1 5, you lose $13. Okay? So the expected value would be equal to this probability multiplied by this reward plus this probability multiplied by this losing $13. And that makes 0.85, since it's shown in negatives in parentheses, that means it's negative. So instead, let me just take it out of the dollar sign. So, and roll it to 2 decimal places. So the expected value is negative 0.85, which means if you play this game, the expected outcome is that you're going to lose on average 85 cents. That's what it means. Number 9. So number 9 it's kind of a tough question. So it's similar to number 8. A pair of dice is rolled once. So you have 2 dice, you're rolling them, and you lose $9 if the dice sum to 3, and win $13 if the dice sum to 11 or 12. So we need to find the probability of sum equals 3, and then probability of sum equals 11 or 12, right? So I can erase these. And then there's going to be probability of sum equals something, we don't know yet. That's the question. So the question is, how much should you win or lose if any other number turns up in order for the game to be fair? So sum equals anything else. Okay. So we find 3 probabilities, the sum being 3, the sum being 11 or 12, or the sum being anything else other than 3, 11, or 12. So if this happens, the sum is 3, you lose $9. So losing $9, putting negative 9 here. And then if it's 11 or 12, you win $13, so that's plus 13. And then there's going to be some other number winning or losing money so that the game is fair. That means the game is fair. The expected value would be equal to 0, because if the expected value is a positive number, then the game favors you. If it's a negative numbers, then it doesn't favor you. So if it's 0, it's kind of a fair game, because the winning and losing is equally likely, essentially what it means. So let's calculate this probability. So when you roll 2 dice, how can you get a sum of 3? So sum equals 3. How can that happen? You can roll a 1 and 2, right? Or a 2 and 1. you can't roll anything else that gives you a sum of 3. And remember, when you roll a pair of dice, the sample space is always 36, because 6 outcomes for the first die and the 6 outcomes for the second die. 6 times 6, 36. So then sum of 3, P sum of 3 would be 2 possible ways. So out of 2 possible ways, that would be 2 possible ways out of 36. So I hate that when that happens. So just 2 over 36. Okay? And then getting a sum equals 11 or 12. So how can you get sum of 11 or 12? You could, let me just put it here. So you could roll, so 11 can happen 5 and 6, or 6 and 5. You can't roll 4 and 7, there's no 7. And that's it, only 2 ways to get 11. And then one way to get 12 is 6 and 6. So in these 3 possible combinations, you can get a sum of 11 or 12. So probability of getting a sum 11 or 12 would be 3 out of 36. And then anything else, so basically not 3, not 11, not 12 would be, again, instead of trying to find the sum of 4, 2, 4, 5, 6, 7, 8, 9, 10, that would be just too complicated. We just subtract these 2 from 1. So subtract that from 1 and then that from 1. And this would give me the probability of getting a sum anything other than these outcomes. So the expected value is, so the expected value of these two would be this probability times -9 plus this probability times 13. So that makes that. So in order to get from the last part, then I should get negative this as the expected value. So how do I get negative 0.5833? By getting 0.86111 times this probability. So that would be actually this number divided by that probability. So then I should lose, so this is, I should lose if I just round it. I should lose not win. How much? 68 cents, so $0.68. So that's how much you should lose if you get a sum of anything other than 3, 11, or 12 to make this a fair game. So the expected value of these two situations turned out to be 0.58. So let me just round these. And in order to make the whole expected value 0, then the multiplication of these two should give me a negative 0.5833. So then if I just divide this by this probability, I get the dollar amount that they're asking, and that's $68.68 negative. Alright, so last question here. Okay, so I don't have too much time left to explain this last question. So this is similar, a 5-card hands, and if you get at least 1 3, you win $11. Otherwise, which means you get no 3s, anything but 3s, you lose $3. So first calculate, getting no 3s is easy because the first card can be, there are 4 3s in a standard deck. So that's 48 cards that are not 3 out of 52.